Hello, algebra students. Mr. Lawrence here, and we're going to do solving by substitution day 2. We're going to run into some special cases. Remember, we talked about sometimes two lines might intersect at one point, in which case there's one solution. That's what we did last night. But two lines don't have to intersect, right? They could end up being parallel. I know these are only rays, but I'm trying to make this as quick a video as possible. And then sometimes we get that unusual case where it's actually the same line showing up twice, right? Two different equations, but they're actually the same equation, once just in disguise. So we're going to look at what happens algebraically. Now graphically it's pretty easy to see, but algebraically sometimes kids get a little bit confused. So let's do a couple special cases. So let's do problem 1. I'm going to solve by substitution. Y is already alone, so I'm going to take this 2/3 x minus 5 and I'm going to substitute it in for y. So I've got 2x minus 3 times quantity of 2/3 x minus 5. All right, now I have to distribute here and here. And when I do that, I'm going to get 2x minus 2x, right? Because the 3's would cancel. Now, be careful because the 3 isn't canceled when I multiply by the 5. I have to multiply -3 times this, and I have to multiply -3 times -5. So there's two multiplications going on here. So that 3's not gone. It just canceled in the multiplication here. So -3 times -5 is 15, and that needs to equal 7. I forgot that from my equation. Sorry about that. Now, if I combine like terms, these two cancel out, and I get 15 equals 7. Let me ask you this, Mr. Cooper. When does 15 equal 7? Gee, Mr. Lawrence, it never equals 7. That's right, Alex. Good job. This system will have no solution. What do you suppose that means, Sean? It means you can't do it. No! No. It means the lines won't cross. Hey, Sean, what kind of lines don't cross? Parallel? You're right, Sean. Very good. The lines are parallel. If you check the slope on this first equation, it's 2/3. If you check the slope on the second equation, it's 2/3. There's no solution. These lines won't cross each other. So that's what ends up happening. When you solve algebraically, you get an untrue statement because the lines never intersect. Never. Now, Kelsey, I'll bet you can take a guess of what will happen when you get an always true statement. Let's try it first. All right, Kelsey, very good. We'll try it first. Okay, here I have y already alone. And so I'm going to take this and substitute it in for y into that equation. So I will have 6x minus 4 times the quantity of 3/2x minus 3. And I'm going to distribute. I'm going to get 6x. A -4 times this, well, let's see, 2 is going to go into there, -2, it's going to be a -18x, I think. No, -6x, excuse me. -6x, sorry about that, doing too much in my head there. -6x. Okay, and then here I'm going to multiply, and I'm going to get 12. Oh, and that's supposed to all equal 12, isn't it? Okay, and so these will cancel, the like terms, and I'll be left with 12 equals 12. Look at that, it's always true. Where do these two lines intersect, Kelsey? Everywhere? Exactamundo. Good job, Kelsey. This has infinitely many solutions. Infinitely many solutions. Yes, it means that they're actually the same equation. If I check the y-intercept on this second one, the y-intercept is what, 0, -3? And the slope is 3/2. Let's go to the other equation. The y-intercept, look at that, make x 0. Yeah, 0, -3. What's the slope? Well, the slope is 6/4, which reduces or simplifies to 3/2. See, there's the same line in disguise. Okay, you might not have noticed that, but it has infinitely many solutions. All right, so 3 things could happen when we solve a system. You might solve, case 1 is like what we saw in the video last night. Case 1, you might solve and get an x and a y, right? Get the place where they cross. Case 2, would be you get a situation that is never true. You get a statement like 5 equals 7. 5 never equals 7. Okay? This top one implies that there's one solution, namely when at x, y. That's where they cross. This one implies that there's no solutions. The lines never cross. Never, 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 never cross. They're parallel. Okay? And then case 3 is where you get a statement that is always true, like -3 equals -3. When does -3 equal -3, Colton? It always equals -3. Come on, silly goose. Oh, I'm sorry. I sound like Derek and Sean now. Excuse me. All right. So, excuse me. So this means there are infinitely many solutions. Okay? There you go. So, here's what you're going to do. We've got a video quiz. Yeah, it's been a little while. This is going to be due Monday, March 23rd. You can put that date on it. Okay, that's the date I'm going to collect it. Solve these 3 systems. I think, if I remember right, one comes out to no solution, one comes out to infinitely many solutions, and one comes out to one exact solution. So there you go. That's your video for tonight. Mr. Laurence signing off. Have a good night, everybody.